Possiamo quindi cominciare. Benvenuto a tutti I
We
partecipanti.
can begin, and welcome to all of you, those who are here in this room, and the 60 or 70 participants who are on the digital platform. So thanks to all of you for being here. And a special thanks to Minister Maria Cristina Mesa for being here right next to me. It's rather special to have you here. Our chairman, Giulio Tremonti, is not here because he has self-suspended himself as a candidate in our next elections, which will be taking place Sunday. So we'll be having him with us at Aspen from Monday onwards. Today, we are giving the Aspen Prize for Scientific Research, a prize which we set up 7 years ago. And we're really satisfied with the attention that this prize has, the number of participations and candidates that every year has grown. So we hope to be able to continue in the future. The prize is the Aspen Award, and it's based on 2 fundamental values. First is transatlantic cooperation, of course. Aspen was born in the 50s in the United States, and one of the main aims was to reinforce transatlantic cooperation. And the other is the promotion and widespreading and growth of scientific culture and its applications. As I was saying before to Angelo Petroni, if we go and look through the program of a year of our Aspen, Italy, we see that the theme of scientific knowledge and research and innovation is more present compared to some years ago. So it's a commitment that we've grown with, it keeps growing with us. And that goes together with the commitment that Aspen US started with a program at a world level, which I'll then ask Angelo to say a few words about. He'll tell you what it's all about, and we too participate in that. The Aspen Prize is given to the best research in natural sciences, and it is, as I said, in cooperation between universities in the States and in Italy. I want to thank the members of the jury. I'm part of the jury together with Giulio Tremonti, and the others are Professor Cristina Alberini, Professor Alessandra Bonanno, Professor Domenico Giardini, Professor Luciano Maiani, and Professor Giovanni Rezza. And to the winning research, we ascribe a prize of 40,000 euros. And if anybody's interested, for some days now on our website, the tender for the 2023 prize is already open, and you have to present registration before January 31st. So anybody who's interested can express his candidature for next year's prize. The widespreading of culture and scientific knowledge is one of our pillars in the activity that we do. And we're really glad here to mention a project that was set up a few years ago by Aspen US on the widespreading and knowledge of scientific knowledge. Now I'd like to ask Angela to say a few words on this program. Thank you, Angela. Thank you. About 3 years ago, Aspen Institute US, who is our headquarters in the world, upon suggestion of Aspen Italy, launched a program which is Aspen for Science. Aspen does pure scientific research. Now, what is the logic of this project, you might ask? Appeals for greater science. There are many for science and pure science and research. They're done by scientists. And we professors of philosophy ask for more chairs in philosophy. And generally our pleas are ignored because it means that everybody might have their own interest in asking for this. But the real point is the public opinion, the cultured public opinion of many countries all over the world, and of Western worlds especially. And we launched this program, which has done a lot, and as you see, will be giving everybody the results, accompanied by research which we undertook in Italy, thanks to excellent researchers at ISTAT, and one is part of the Frascati group, which is the group that measures investments in research and development, where we see that the expenses in research and development in the world, unfortunately, are not on the increase. They're stable. But the worst thing is that the part for pure research is constantly decreasing in favor of applied research for technology, which is not good news. But since we are in a democracy, the politicians are rational. And obviously, if they do this, it's because they think that public opinion does not appreciate enough the investments in pure research. So we need to convince public opinion and start from there. So our motto is enlightened leadership. This is the motto of Aspen. We try and do our duty in this case, not compared to many other subjects that we deal with, but compared to the basic research. Thank you. Thank you, Angelo. And now, as is tradition in the ceremony for the prize award, the ceremony first has a meeting and debate, which will be taking place now. And the theme of the debate today is young and scientific training. To direct this debate, we have Professor Luciano Maiani, who is the soul of the committee for the soul and the mind of the choice of the winner. And Professor Maiani is known by all of us. He's emeritus professor of theoretical physics in the Sapienza University in Rome. You have the floor. Thank you. And I'm very glad to be able to moderate this discussion on such an important theme, such as that of youth and scientific training. I don't want to take too much of your time, but I just want to remind you about the importance in scientific training, about those who do the training, about those who, one way or the other, are the target, the model that the subjects that are to be trained find inspiration in. We were lucky enough to live in a period, I'm speaking of Italian physics, we had extraordinary personalities, and these were a source of inspiration for us. And I want to stimulate you to pursue training at the highest level. I will now give the floor directly to Professor Alberto Quadricurzio, who is President Emeritus of the Accademia dei Lincei.
Thank you very much to Aspen for having invited me. And in particular, I wish to thank Aspen Institute for having been innovators in connection with this award. The award, which is given to research groups through the cooperation between Italy and the United States. It is important to acknowledge talents, and it is important to bring together different scientific cultures. We need this kind of interface because, as economists say, this way they create economies of scale. I do believe that Aspen Institute is an ongoing innovation effort, not only when it comes to this award, but when it comes to all of its seminars and debates, because they bring together different people with all sorts of expertise. And this results in cultural growth and improvement, but it also drives innovation. And I think that this is one of the parts of this innovation drive, this award. I must say that Aspen has always focused on the need to cultivate, to foster the history of science, because the history of science is extremely important. It is an essential part of science itself. And in addition to the history of science, I think that even the philosophy of science might be useful in our debates. In some scientific faculties and departments, they're currently offering courses on the history of science. And I do believe that we should always hold on to this kind of teaching and this reflection, because these are long-lasting programs, and we need the creative talents to hold on to this kind of knowledge and learning. Angelo Petroni was saying that, in fact, this is very important himself. Let me just make two personal remarks. Tomorrow at our academy, l'Accademia dei Lincei, we will have some events which we've organized. In fact, tomorrow we're celebrating Vito Volterra, who was a genius in all the areas of knowledge that he worked in. He was a genius in mathematics, in physics, possibly not as well known for his contribution to economics. His mathematical model was widely applied in economics. So Vito Volterra was brilliant, especially in his time, and he was also very expert in the history of science. He enjoyed it tremendously, and he was a driver of innovation. And he said all scientists always had to bear innovation in mind. At times, some scientists think that they've invented the latest invention, but history is full of inventions that have piled up over time, as it were. We've had lengthy discussions with Mr. Petroni, and in fact, at one point, we spoke about something that I often mention. I think it's very powerful. It's very emblematic when we talk about knowledge. And this is the icon of Federico Cesi, of Galileo Galilei, and Cristina Messa. I'm sure has heard this repeated many times. I hope she doesn't mind if I say it yet again. Perhaps this might be seen as a form of inertia. In any case, the saying was the freedom of philosophizing in naturalibus. They were two geniuses. One was a literary one, the other one was a scientific genius. And in my recent analysis of these two persons, especially Federico Cesi, I identified a new thread, which was expertise and skills in fields that, well, for example, he was an advocate of Galileo Galilei in his time, but also because he had a varied sort of brilliance, as it were. So he cultivated many different areas. Conclude with a saying or a phrase, a sentence from 1931 by Volterra, Vito Volterra. That was a terrible year for Vito Volterra. He was a Jew. It was a terrible year. And this is the saying, this is the phrase. I will mention this tomorrow, in fact, in our event. Empires are dying, but Euclid's theorems will live forever. They will be eternally youthful. They will have eternal youth. So this was the sentiment, the feeling of a man like Vito Volterra, who was, of course, a great scientist in our country and also in the universe of science overall. I do thank you for having given me the chance to speak to you all this evening.
Professoressa Marica Branchesi, Science Institute del Kansas.
Now, thank you, Aspen, for having invited me and for having given me the possibility of speaking at this conference. I am professor at the Gran Sasso Science Institute, and I'm very happy to be able to work with youth coming from all over the world. I am with them when they're at their beginning of their research, And I have the possibility of working with them and get them to know what the beauty of science is. They can become independent researchers, and then they take flight. And the best aspect of my work is exactly this. Today, we're here to give a prize to research that I am particularly fond of because it's a prize in astrophysics, the new exploration of the universe through gravitational waves, this new astronomy, which is unveiling what was obscure before. And here we see that quality research is receiving a prize. It is an aspect which it is important to think about. And we must think of quality research. Today, we are in a moment where we see that at an international level, research often is assessed quantity-wise rather than quality-wise. And this is a big weight for the young, because I've seen this aspect change since I graduated over 15 years ago. And I think the time has come to think deeply, because for the young, the pressure is great, and they're not able to live fully the most beautiful moment, that of tasting the times and the time of research. Something else which is important in this country, which is that there's a bit of inertia in giving young scientists a research and responsibility in research and having roles of responsibility. Another aspect of the prize today is cooperation. And all of the discoveries of the last couple of years, from it's in the discovery of gravitational waves, makes us understand that today the great scientific challenges can only be overcome through collective discoveries with the cooperation of many scientists to put together their diversities, their different experiences, theoretical, observative, informatics, engineers all together. And this is a great example for the young and for society, because it's an example of how important it is to pull down walls and to build bridges, because science has to be a message of bridges of peace, especially in a moment like this where we have a war so close by. I think science has to carry out this role and has to be an example for all of the young. Thank you. Many thanks. And now we give the floor to Antonella Polimeni, who is Dean of the Sapienza University in Rome.
Thank you very much, Madam Minister. Good evening, everyone. Thank you so much for this invitation. And thank you to Aspen Institute, Italy, for having invited me, because this gives me the opportunity to just make some very short comments, very brief comments on this meeting on youth and scientific education and training. Our youth are clearly the most important resource in a country like ours. There have been great transformations here. The world has become globalized. And the past few years, we've had disruptions during the COVID pandemic, for example, and we are still in a rather troubled time. The international situation is quite complex, and yet we have to keep underscoring that competition has become international. It plays out on an international scale, and therefore culture and education are going to be ever more important in that area of knowledge, and universities have an important role to play. Our university has been around for centuries, and I must say that we've had to deal with huge transformations. It's a general public university, a state university, which offers education and research opportunities for everyone. But of course, Our focus is scientific excellence and promoting merit. Culture and education in the world of science has to be shared and open to dialogue, not only within the scientific community and academic community, but there has to be a dialogue with society at large and with the country overall. So Aspen Institute Italia plays a leading role in trying to internationalize our transatlantic relations. And in fact, we know that they are focused on scientific and technological innovation, and in particular, the importance of all this for our country. We've talked about innovation. This is a process which, of course, is always proposing something new, and it must always aim for some sort of societal benefit. Scientific research and the teaching that occurs in universities. We also have a third mission now. Well, these are an important premise for all innovation processes. And these are prerequisites, and they're not always sufficient, though. And yet, this is what we need in order to achieve our results. But there has to be an interaction with society, because research can come up with an innovation, something novel, but societies have to accept those novelties. So we need to stimulate segments of our society, the youth, our industry, because they are the ones who can be a driving force for innovation, which will lead to social benefits and advantages. In other words, we can improve the lives of many people through these kinds of innovations, perhaps even everyone, I would say. When we speak of innovation, we need for there to be contacts where there are ideas, where there's free research, pioneering efforts, the industry, and universities. And these contacts, of course, need to have the universities on board, as I said. So universities not only play the role of mediators or intermediaries between youth and businesses, but it is a place where we can educate and form our youth, provide them with the knowledge and advanced skills that they're going to need. That way, they can become an active part of our industry, our industrial system overall, and the world of production. They can help to build up a society which is ever more fair and inclusive. So I must say that the aim of this initiative is excellent. You want to promote and foster research theoretical science, and this all has to be done at a level of excellence. This is indeed important because a network is what is needed when we talk about innovation processes. It is a way of building up links and linkages around shared research projects, and then this network has to grow exponentially. That way we can promote research. We need many energies to do this, so even the National Resilience and Recovery Plan has this mission. In fact, there are 4 universities that are on board there. We're working on this project. So let me just wrap up by saying something that Albert Einstein said: research is truth and very precious. So this is important for all the new generations involved in scientific research. Thank you. And now I'll hand over to the Minister of Research, University and Research, Maria Cristina Messa.
Thank you. And I too wish to thank Aspen, and I wish to congratulate you for setting up this prize and for the edition of this year. I want to briefly go into 3 items on this theme: training, which is in the title, training of new researchers and cooperation. Now, for training, of course, there is one fundamental point. I know you thought about it, and I know you've often talked about it. It's the question of the issue of school. If we want to talk about scientific training, we have to talk about school, starting from school, starting even from kindergarten, from the very beginning. Science has to be treated in a much different fashion. And when I speak of science, I mean science in the general sense, not only scientific subjects. The whole scientific thought is what I mean, with a scientific approach to problems, a scientific approach to humanistic subjects too. So I think that this is one of the fundamental issues. Then when they get to university, of course, choices are conditioned by what a school is able to give. We know that the recent data tell us that our young who register for so-called STEM scientific subjects in 2021 are 24.7% lower to percentages in France, which is 27%, Spain 27, Germany 32. So anyway, we are not very far, but certainly in the relationship between these three countries, we have a lesser percentage, less people going towards these scientific subjects, even if the last 5 years we've had an increase. Because in 2016, there were 85,000, and now instead there are 94,000 registering for scientific subjects. So they're on the increase. But it is a country that has a tendency, has always been more in leaning towards humanistic aspects, and scientific subjects have always been considered a bit difficult, distant from our country. I think that this ought to change, and in order to change, we have proposed in this year and a half that we try and overcome this antithesis between scientific subjects and humanistic subjects, and try and find what connects them through interdisciplinarity, through the definition of new journeys and courses, so that classes should not be tied only to the discipline, but should go beyond and see things slightly differently, even if they're aware that then what goes deeper has to be vertical. But of course, we must not forget the possibility of having transversal courses. This change in training is essential. And it is what other countries have already done for quite some time. In the Anglo-Saxon culture, this is quite widespread. There are no boundaries in working on these degrees. It depends on the market. Of course, there's different rules, but it allows for more flexibility, which is important. And it is important for the young. And I think that it's very important within research today to reassure the young on their autonomy, on their responsibility, and also on their support, which they can get from the institutions. Institutions have always been close to the young, but more at a peripheral level, yes, less so at the central level. Governments today, even the electoral campaign speaks very little of the young. Maybe there's not enough young to be interested in having and considering them to be a population of reference, but they are the ones who will go on with the job of going forward. So from the scientific point of view, more responsibility, more recognition, a great deal of support from institutions, I think, is necessary, more than necessary. What we've done is we've set up new projects for research, for basic research, Italian science, applied research, applied science, but especially what we're trying to do today is to give the possibility to those who won large projects abroad, like RC or Marie Curie or other, to come and do this research in Italy through programs of great incentives, both for those who want to come over and for the structures that will be hosting them. And in the same way, as we were saying before regarding fundamental research, we've also worked first with a group who started under Professor Mayani, who's here today, and Amaldi, and then with another group we set up at the ministry coordinated by Luigi Ambroso, the dean of the Normale. We set up a plan for fundamental research, which can more or less define investments. For the future, especially, we don't want to take steps back when these 5 years of PNRR will be over. I want to conclude talking about cooperation, since we start from a prize that sees a great deal of cooperation at a transatlantic level with the United States. We have 15,000 Italian researchers in the United States, and these are increasing by 6% a year in the last decade. So there are more and more. Now, I don't think that it will be possible to think about a policy, a national policy, or a policy of re-entry or reduced boundaries or frontiers. I think that we have to establish relations with our Italian researchers in the United States, make them stronger, more widespread, so that ever more they can bring to the circulation of brains that we all aspire to and which we all have great faith in. Thank you once again. Thank you, Minister, also for being so within their time limits. I want to thank everyone for this. And now we can open the discussion. I wish to remind you that you can book your intervention. The people who are here raise their nameplate, and instead those who are participating via Zoom click on their raise hand button. Now, the first who's asked to take the floor is Francesco Tombesi. Good evening. Thank you for the invitation. I'm Francesco Tombesi. I'm an associate professor in astrophysics at the University of Rome in Tor Vergata. And 5 years ago, in 2017, I had the great honor of being one of the winners of this great prize. At the time, I just come back to Italy, thanks to the project, Montalcini project for the re-entry of young researchers. And it was great happiness for me because finally I had understood that, in fact, Italy too is able to give value to basic science and young researchers. Of course, then, as we heard, there are very, very many Italian researchers abroad, and they're even happy. I'm even happy this evening to see a theme which has been received the prize in astrophysics, which has to do with my studies on black holes. And there is one colleague of mine, Mr. Mazzo. We were together in the States. This was in 2010. This was my first time when I was working at NASA, and we were both, we didn't quite know what was going to happen to us. We didn't know whether we'd be coming back to Italy at all. What would we be doing? But we started working, and that experience abroad in the United States, in cooperation amongst Italians and foreigners, was what gave us the opportunity to come back. And I remember that we saw the simulations that Bruno is launching on his computer. I didn't quite know what they were. Then there was the discovery of gravitational waves, which showed that these astrophysics objects are real. And this evening, I'm really curious to know what this new discovery is. I conclude in saying that training abroad is awfully important, but I have noticed in my experience and the experience of others that there is a critical point. There is not much elasticity in the Italian system to attract both Italians and foreigners. Another example is a researcher I know that I work with now, who's in Chile, in Santiago, where the greatest European telescopes are. And she's trying to get back to Italy if they don't give her a job first abroad, but she's got to go through competitions in presence with a handwritten composition, and she's got to come back again for the oral test. And these are limits, both for Italians abroad, because of course there's flights to pay, and also it's a wall for foreigners. So the experience that I, Bruno, and very many have had in the States is something very few other Italians can have, because there's a lot of limits to entry. So I'd like to ask the people here today, what points can be brought forward to help further, to facilitate the opening of the Italian system? Thank you. Thank you. And now the floor to Alessandro Golcan. Good evening. I'm Alessandro Gorka, and I am an ordinary professor of the Technical University of Munich in Germany. First of all, congratulations for those who this year are receiving this very important prize. And I want to share some thoughts, which I feel I am in agreement with listening to the debate today. It's not just a question of supporting the young, but also of stimulating in young, from school onwards, a culture of leadership. Often, especially in Italy, we listen to this method that we have to be supported, or we need work and opportunity for the young. But sometimes what we need is just courage, just plain courage, the courage to risk, not necessarily a course that has been traced by others. It means risking going abroad, somewhere else, leaving one's own home and work. And this, I think, is something which I think is very important. The opportunity, which in Italy we should always try and use results from the world of astrophysics to do something elsewhere, apart from publishing, could have an important impact on society. It already happens because Italy invests a lot in commercializing science, and the hope is that maybe we'll evermore continue doing this, and that this will be transmitted to new generations, starting from school onwards. Thank you. Very many thanks. The next speaker is from this room, Gianni Letta. Just to say thank you very much to Aspen for this initiative. A true thanks, which I'd like to say especially for President Tremonti, Mr. Petroni, and Lucio Stanca, because the inventor of this plan that has defended and brought to success is the prize success is he himself. What I wish to say is simple but very bitter. Today is September 20th, and there's only 3 days left for the conclusion of a frenetic electoral campaign, and we had to come to Aspen to hear a word at least about research, because I never heard the word research expressed in the themes that we've been listening to in the very many debates which have flooded our televisions with masses of chat, and often with very little conclusion. Whereas here instead, we've had a true testimonial of what can be done, what this prize has generated. The testimonial that Professor Tombesi gave should be a great electoral manifesto. This really should go on television and be debated upon, just like that of what Alexander Gorka said. But the experience of Gorka, who I know personally and who I have a great esteem for, and what Tombesi said show, in fact, that there are very many young who go abroad and they're all successful, which means that the training that our university gives is good, is competitive, because certainly these are the best and they deserved all this. But if they didn't have a proper training, a competitive training, maybe they wouldn't have been able to all be as successful as they've been in these different subjects and in many parts of the world. So whereas this confirms that our university basically does come from a school which is maybe not suitable to the times, and therefore maybe the material is so-called raw material. At least they know how to work this raw material and give it to the world in a very competitive fashion. And we should also think about the themes of university. So bitterly, as I was saying, I think that all these themes are absent in our election campaign. So thanks to Aspen, and thanks especially to Mr. Stanka. Thank you. We still have enough time for another couple of questions. I'll have you remember that to take the floor here, you have to raise your nameplate, and in remote, you have to push the button raise hand. Mr. Mariani, can I take the floor? I'm Quadrio Curzio.
I was listening to all the important comments and remarks made even by our two colleagues who spent a lot of time abroad. So let me just make a couple of points. I don't really know much about elementary school or middle school. I finished school a long time ago, but I don't think that they teach the history of science in those schools. I'm pretty sure of that, but I think it would be important. I think that children need to study the way states have been created and all this, but they don't study the history of science, and they should. Now, there are some European countries that have museums of science and technology that are very close to one another. So people can easily visit these museums. This is very important because youth mustn't only learn by going to school, but they learn by observing and seeing things. That's very important, I think. One last point. Let's take two Italian museums. And I see that youth go to these museums, lots and lots, throngs of youth. One is the Leonardo Museum in Milan, and all sorts of students go there, and the Galileo Museum in Florence as well. They teach youngsters in an extraordinary manner. You've got to realize that our youth don't only have to listen to learn, but they can watch to learn as well. This is something that we've got to bear in mind. Thank you. Giovanna Dossena has asked for the floor now.
Grazie. Grazie, contributi importantissimi. Io forse con il mio intervento restringo l'area a
I've heard some excellent remarks. I would like to focus on the interaction between the world of science and the economic system. More and more, our societies are liquid, they're open, and innovation is brain intensive as well. So the awareness of science is the enabling factor for science itself. Technology transfer must be seen as being a two-way street from market to science and from science to market. And this is how we should learn how to drive science in general, to stimulate it. Now, we also need to communicate science. We have to make sure that it is widely perceived by everyone. It must have a very broad scope to be perceived and to raise awareness, because not everyone has this awareness, this perception. Maybe we would improve our attractiveness if we could simply communicate things differently. It should be a more targeted, more widespread kind of communication. We need to find the right language to use in order to raise awareness of society overall when it comes to science. And this is exactly what Aspen is doing beautifully, I must say. And I think it should become a way of doing this in other areas as well, in civil society and in other sectors, because this is how youth learn how to perceive and then interact with society overall. Yes, thank you very much for your contribution. Perhaps we can go back now to our speakers, and we can follow a reverse order at this point and give them a chance to reply to some of these remarks and comments that we've heard. We can begin with the Minister for University and Research, Minister Messa. Thank you. Well, first of all, I'm very happy to know that Rita Levi-Montalcini effort has been successful, and we're trying to have more of these programs and projects with our National Resilience and Recovery Plan. So youth need to know that this is an option which is available to them. It isn't only a question of being able to carry out research when I talk about an option for our youth, but it's a question of being able to be in a positive ground for them to operate. When I talk about a ground, I mean they need infrastructure, tools, equipment, but it's also a cultural ground. The culture of good science means to enhance researchers and the work that they carry out. That's why I was speaking about autonomy earlier and independence, because this is how they can be great. They have to be independent and work with their own resources to the extent to which this is possible. So I do agree that you need to be courageous and take these risks. And I must say that I was I was impressed by what I read this week on Corriere della Sera Daily. They wrote about the fact that there are layoffs. About 1 million people left their permanent job. They used to be highly sought, but they're looking for something that is more satisfactory. So I think that that new generation is already there. They are able to run these risks, and they clearly are in the forefront of this effort. What I would like to see is for this generation to either be involved in basic research or applied research or industrial research. In any case, they should be able to work on innovation in the broad sense of the term. Through science and through education, you can leave a mark in scientific publication, any sort of instrument that would make Italy productive. In other words, it would make Italy a country where new technologies are produced on its soil. And this is something which would result in growth for our country. And this is what our youth can do. We mustn't lose them. We mustn't lose them at all. We know, in fact, Mr. Letta said that not much is said about innovation. In any case, we're talking about 14 billion for university research in the National Recovery and Resilience Plan. So we mustn't lose this opportunity, this allocation, as it were, and it must result in a long-lasting outcome for this sector. Thank you. Thank you. And now we have Director of La Sapienza, Antonella Polimeni. Let me go back to what our colleague, Mr. Tombesi, was saying earlier. He was speaking about the difficulties in simplification. So we talked about the fact that our youth have left our country. We'd love to have them back in our centers. We need to facilitate the mobility of our youth to make sure they are able to come back. We have to work on this. And there are some constraints, however. It is impossible to negotiate salaries. And clearly, this is one of the most negative points, and that is why they don't come back. In any case, the individual universities can try to improve the salary scale, the pay scale. We just adopted some regulations which will enable returns to our university with an exemption of their teaching requirements, for example. So they could teach less and do more research, basically, by coming back to our university. We know how difficult it is, of course. There are some colleagues who cannot move about. Maybe because there are exam requirements, written exams, but I suppose that can be changed. So let me just focus on the fact that in our country, we need to communicate more on the subject of scientific culture. Our citizens don't know much about science, and that makes us a weaker country. So this is perhaps this should be one of our drivers for the future. And as Minister Mesa was saying, it's not a structural measure, but it should be a sort of enzyme, a catalyst, which will help us to think this through. And when we talk about education and research, we need to have a greater focus than what we've heard over the past few weeks during the electoral campaign, as Mr. Letta was saying. In fact, they haven't talked much about that at all. Marica Branchesi. Yes, it is hard for foreigners to be hired here in Italy. In fact, often the calls for proposals are in Italian, and we have certain procedures that need to be followed. Now, in other countries, they simplify these procedures, and clearly that makes it possible for foreign researchers to come to Italy and to apply for these positions in Italy. And this is something that we need to improve in our system to simplify the recruitment process. There's another important point, and that is resources for youth who are not yet in universities, who don't have positions in universities or research centers. We talked about Italia Montalcini. I haven't been abroad that long, but I came back to Italy thanks to FIRB. So there are people who are not yet part of our system, but who can return. And mobility, of course, is important because going abroad is an enrichment. The fact of being able to go and even come back means that foreigners that might choose Italy to come and research here. So we're lagging behind other countries in that respect. We want the foreigners, foreign researchers to choose to come and work in Italy. That's why we have to simplify our regulations, our laws on recruitment and hiring. We need to make this happen more simply as they do in other countries. Thank you very much. And now Alberto Quadricurcio. The Aspen meetings, such as this one and others as well, well, one of the goals is to have an exchange not only of views, but of information as well. So I wish to thank Giulio Tremonti, Lucio Stanca, and Angelo Petroni, because they have supported this early career fellowship for the organization of women in science in the global south. That's a very important initiative. It's a scholarship, an early career fellowship. What does it mean, early career fellowship? Well, It means that these young female scientists earn a degree, they get their PhD, and then they work in laboratories, even industrial laboratories. So this is quite important. And this organization of women scientists in the Global South is very careful in choosing sponsors and scholarships for early career fellows. And it is important to acknowledge what they're doing. A second piece of information. At the OWST General Assembly, Cristina Messa spoke, and Maria Chiara Carrozza and Fabiola Giannotti, they all spoke at their General Assembly at the OWTS. So 3 Italian scientists who spoke at that online assembly, I believe. There were about 15,000 scientists of the Global South, scientists who work in all fields of science. In all of these countries, science is applied. Is an applied science because of the situation in those countries, the dramatic situation. Even during the pandemic, extraordinary work was done. So it is important for our youth to be involved.
Grazie Alberto. Io volevo, in chiusura di questa interessante giro di opinioni, volevo
Okay, this is a very interesting exchange that we're having.
un'indicazione che è venuta dall'intervento di Giovanna Dos
And Giovanna Dosenna said something that I wish to go back to. She talked about technology transfer and research and industry. Clearly, this is something which is dear to all of us. And youth, of course, are involved. And she mentioned the opposite route or direction from industry to research, not only from research to industry. And this is important, especially for basic research. Let me just underscore this fact. Basic research at times is seen as something which is very distant and remote from reality. But in actual fact, the fact that they're dealing with very difficult problems and issues means that the instruments used in basic research are not always available. And this is how industry might be asked to develop something new technologies, for example, that will then be used in basic research. I have direct experience with this through my work at CERN. It's a typical example of how basic research can develop and promote the request for technology, which you just don't buy off the shelf or from a catalog. It's something that has to be developed deliberately, intentionally. So this is important when we talk about science and society. I just wanted to underscore that. Okay, I think we can conclude this debate now. And I wish to thank everyone. Let me extend my greetings to the minister who might have to leave before the end of our ceremony. Well, I thank you very much, Minister, for having come this afternoon, for your contribution and for being so encouraging. So I will now hand over to Lucio Stanca now, and we can move on to the award ceremony.
Thank you. Thank you for all those who have taken the floor. And I just want to make a little comment very quickly on this discussion. Going back to the project of Aspen and our American friends, this project of increasing through communication the understanding of the role of science in the era we live in, the awareness of the opportunities that science can open, a great effort of education of the peoples and of common people. I mean, people who every day are far away from science. In Italy, this effort needs to be even greater because we are missing the great enterprises, the great budgets for research, which through their research, communicate and promote, because this is a fundamental asset for their business. And having instead a few and large enterprises and too many small enterprises who don't do research, and or at least who don't do basic research or advanced research, what happens is that we truly have an even harder task, a great commitment, and this is why we like to commit ourselves to this project. Before passing on to the program, since we talked about young and scientific training, I wanted to mention an initiative which is about to be made public in the next couple of days, which regards the setup of 10 university scholarships to female students of the southern part of Italy who enroll in STEM, in the scientific subjects. 11,000 euros for each scholarship. They have to be under the age of 20. They have to register not in a faculty where they reside, obviously, otherwise they wouldn't need a scholarship. And finally, the award, which is taking place just now on the basis of merit and economic conditions. This is our little contribution to helping the young girls of the South to come closer to the world of science. Now, having said this, we are at the moment of the award, and the 7th edition of the Aspen Prize is given to the research observation of radio signals and X-rays show the presence of a relativistic jet between the material from the material of neutron stars, and because this is because of high scientific value that the prize is given, and research shown that these neutrons can launch a jet of energy which is so powerful as to produce a blare of gamma short rays, bring to end the decades of doubts as to the exploration of these as the most luminous of the universe. On 17th October, the detectors observed for the first time in the United States the waves produced by the fusion of two stars of neutrons. The event took place in a galaxy 130 million light years away and was also observed in different frequency bands of the electromagnetic spectrum, including X and gamma rays and infrared optic and radio signals, thus bringing to the beginning of the era of multi-messenger astrophysics based on the combination of gravitational waves and electromagnetic signals, a novel field of investigation that holds great potential in the years to come. Now, I won't go into the details, of course, because my understanding of the motivation is limited, you understand. But before giving the floor to the two scientists of the team who have conducted this research, I wish to mention the whole team, all of the 8 scientists who won this prize. The scientists in Italy and in the United States, Professor Davide Lazzati, director of the Department of Physics of Oregon State University, Professor Zalba Perna, Department of Physics and Astronomy, Stony Brook University in New York, Professor Brian Morrissey, Department of Astronomy, University of Maryland, Dr. Diego Lopez Camara, Institute of Astronomy of the National University Autónoma of Mexico, Mexico City, Dr. Matteo Cantiello, researcher at the Center of Computational Astrophysics of the Flatiron Institute in New York, Dr. Riccardo Ciolfi, researcher at the Astronomical Observatory of Padua of the National Institute of Astrophysics, Professor Bruno Giacomazzo of the Center for Physics at the University of Trento, and Professor Jared Workman of the Department of Physical and Environmental Sciences of Colorado Mesa University. This is the team. These 8 are the winners of the prize, and now I want to give the floor first to Professor Ciolfi, and then to Professor Razzati, so they can explain in understandable words for all of us the value of this research. Thank you. Hello, thank you very much. I'll take the floor, and thank you for this introduction. Before anything, and on behalf of the whole team, I can say that we are deeply honored for this award. The fact that a jury of this level has judged our work to be at the height, worthy of this prize is wonderful. I speak on the Italian side. This is mainly an Italy-United States cooperation, which is the intention of the prize. And then I'll be giving the floor to Professor Razzati, who is connected in remote, who represents the side coming from the United States. And he'll be the one to present the team to illustrate the key points of our work, and therefore to appreciate the value of the result obtained. And what we need to do, I think, is to make a little introduction. And I'm the one who's been asked to do it, and to introduce the two astrophysical events which are involved in this scenario. Our work is contributed to unify in a single scenario with very important consequences, both for astrophysics and for fundamental physics. Now, the first of these phenomena regards the neutron stars. These are ultra-compact subjects which are formed as a residue of a supernova explosion, which takes place at the death of a large mass star. And they are objects which are extreme from many points of view. They're very dense, they're of extreme density. The density is denser than that of atomic nuclei. Can you imagine the whole of the mass of the sun concentrated in a ray of just 10 kilometers? So let's say a spoonful of this matter is as weighty as Everest, just to give you an idea. So clearly, to study these objects means to study physics in extreme conditions, which otherwise would be inaccessible for us. We could never reproduce in laboratory these conditions. And therefore, we have a sort of laboratory which, through observation, if we're able to interpret it, will tell us how a subject matter behaves in these situations, how the strong magnetic fields work, the more rapid evolutions, everything which is extreme. Now, like for other stars, these subjects too confine themselves to form a binary system, so the two stars orbit one next to the other, one within the other. And here we can show you the first side. You can see that things become really interesting when the distance between these two stars is reduced by effect of the loss of energy in gravitational waves, which is something I can't go into just now, down to the point where they clash and they merge into one single object. So here you can see, as an example, our simulation, which you see clockwise, and it reproduces the different phases of this process of merge of the two objects into one object alone. Now, the energy which is unleashed in this type of fusion or clash is huge. And it's not only by emission of gravitational waves, but also emission of light, or to be more correct, emission of electromagnetic waves. So apart from rays, we see also the X-rays, the gamma rays, and other waves. And these signals are so brilliant and powerful that we're able to see these events even if they take place in galaxies which are far, far away. And that is why we can study these phenomena, which would be extremely rare. Waiting to see one take place in our own galaxy, and we have to wait a hell of a long time. But since we have the possibility of observing these things at great distance, we have a great amount of the universe, and therefore we can see a certain number of these. So this is the first of the phenomena. The second, and here I can put the second side, and this instead is the phenomena of gamma ray burst. Gamma ray bursts. These are in the gamma ray, they're gamma rays, and we're able to observe them up to cosmological distances, really extreme distances, and this is thanks to the fact that their intrinsic luminosity is extraordinary. These are between the most amongst the most energetic that we can find in our universe. And as you see in this slide, this isn't not a real simulation. This is a work of art, obviously. These bursts, these bursts are formed, are associated with the production of jets of very powerful energy, which are collimated. Now, there are two categories of these gamma ray bursts, the long and the short. The long, as you know, are associated with supernova energetics, and the short ones instead. The dominating hypothesis for decades was that these would be the effects produced by the merge of two stars one next to the other. And at length, we waited for confirmation of this, and in the end, the confirmation arrived with the first event of coalescence of these neutron stars recorded in 2017 by the detectors that we mentioned in the LIGO in the States and Virgo here in Italy. And apart from the gravitational waves, this event, we already talked about the beginning of the multi-messenger. And apart from this event produced light and electromagnetic waves through the whole spectrum. And there were observation of gamma rays, X-rays, and radio waves and visible light. And amongst these electromagnetic signals, there was actually a burst of gamma rays as well, which is what we wanted to see. But it was peculiar, it was less energetic, it was a bit strange compared to what we were expecting. And this left a number of doubts in our minds at the beginning until we were able to show that this actually was a short gamma reburst, like the one that we saw up to that point, confirming therefore the origin of these bursts associated with the mergers. And here in this exact passage is where our contribution takes place. So I think that this is what I'm going to get Professor Lazzati to explain to you. He is representatives from the United States, and his task is to enter into the specific details of our work and to present the team. You have the floor.
Thank you very much, Riccardo. Thank you to everyone. I also wish to confirm that we are truly honored to receive the award. Unfortunately, I'm not able to be with you. I am in Italy, but I'm in Otranto. I am attending a conference, and we're discussing these events. In fact, we are discussing what the future holds in store for us. So I must say that this is a timely opportunity to be speaking to you. I must say that I'm delighted to be able to talk about our research results. And let me begin by introducing the researchers the authors of the study that has received the award. I need my first slide, please. You've heard their names and now you can see their faces. I'll start with the first, that's me. And from left to right, Mr. Cantiello, Professor Workman, Professor Morsoni, Professor Lopez Camara, Professor Ciolfi, who just spoke, Professor Sperna and Professor Giacomazzo. Why is it that we needed an 8-person team to carry out this research? As Professor Ciolfi told you, it's a very complex system, the one that we're observing. Initially, it was made up of 2 neutron stars with a very high density, and this requires expertise on these systems. There is an interaction between atoms and the nuclei, and the proton and neutron particles, they change. They're different from what we can obtain in our labs. And then we have this merger between the neutron stars, and this produces another neutron star or maybe a black hole. Who knows? We have to study that. And what mechanism is there whereby the final effect of this collision is a jet which swiftly moves away. It is like the speed of light. It moves away from the clash point. So we have magnetic fields, interactions with plasma, and relativity issues and mechanisms, and even radioactive mechanisms, because what we observe from the Earth are electromagnetic magnetic waves, as Professor Ciolfi was saying, X-rays, gamma rays, and light. That's what we can observe from the Earth. Lights of all colors and of all different frequencies above and below the range of visible light. I wish now to go back in time to 2017. A bit of time traveling here. Let's see what was happening then in astrophysics in 2017. And I want you to understand that an astrophysicist is a rather peculiar scientist, because in many areas of science, there is a laboratory where one can work and conduct an experiment in order to confirm a theory. But with astrophysics, well, an astrophysicist is like a police inspector who comes to the scene of the crime, but the crime has been committed. There are elements, there are some elements of proof which are there. You can't create them, of course. And an astrophysicist receives whatever the universe provides. It's not that we can create something. So it's a work of inference. It's not that we can choose what experiment we want to conduct. Instead, in 2017, this is what I'm trying to say, we knew that LIGO and Virgo had already begun seeing the first gravitational waves, LIGO and Virgo. So we were waiting to see the neutron star system. Now, as theorists, we were having great fun. We were using all of our expertise to try to predict what we would have seen. One of the intuitions that resulted in a series of publications, including the one that's receiving the award today, the intuition was to understand that despite the fact that these gamma ray bursts are collimated, and they're very brilliant only if the relativistic jet points towards the Earth. And even if they are seen from the side, as it were, outside of the jet, in other words, then they would have seen the emission of gamma rays. And this is something that no one had ever considered before. And that was very useful, that intuition. As Professor Ciolfi was telling you a moment ago, in August of 2017, Virgo and LIGO saw this gravitational wave, followed by a burst of gamma photons. It was unexpected, highly unexpected, because the greater probability was that the relativistic jet would move away from the Earth. So we didn't expect to see what we did. Now, we had that intuition and we said, well, then this is a jet that we're seeing from the side. As often happens in science, when you see something that is unexpected, there are many explanations for it. In particular, there was an alternative explanation provided by Caltech in California, by a group of scientists there. Instead of saying there was a new viewpoint, well, there was a short gamma ray, of course, but instead of having a new viewpoint, they talked about a completely different explosion. With our interpretation, we could have united the phenomena, two neutron stars that merge, and they produce a gamma burst, whereas with their interpretation, the two neutron stars merge with a small gamma burst, but it was a different phenomenon. So the gamma bursts that we were seeing for 20 years now should have been coming from a different system. The two models have two different traditions. With our interpretation, we can show the slide here. With our interpretation, because of the fact that the jet was moving in a precise direction compared to where the Earth was, we can see the next slide, please. What we were expecting to see was that even the light source, the radio wave source in the sky, would have moved in a certain direction compared to the stars. In the alternative model, where this would have been a new phenomenon, they didn't expect this kind of movement at all. So we published the article, which is being awarded based on this intuition or on this interpretation. So it was published, and a few months later, the experiment was conducted by an American group and by a European group, an Italian-led group, European group. We're very happy to see that the source of radio waves, of radio signals. So basically, initially, the gamma burst comes from the gamma ray, and then X-rays, and then visible light, and then radio waves. And then when it became radio waves, principally, it moved only very slightly. However, it was measurable, the movement in the sky. And this is an example of what we called a crucial experiment in science. In other words, it confirmed the fact that what we were witnessing was a gamma burst seen from a new viewpoint that we hadn't yet observed. But we inferred from the model this movement in the sky that we were seeing. And we can now have the last slide. Let me just say something about what might occur in the future. What I'm trying to show is that gravitational waves and light, gamma rays, didn't come at the same time. Gravitational waves came 2 seconds before the gamma rays. There was a very small distance that was covered, even though the two signals had traveled for 120 million years in order to reach us. In any case, we saw that the gravitational waves came first. Now, we're waiting now Unfortunately, the sound is
Può succedere. Ci sono varie
not very
ipotesi.
good. So anyway, there are a number of assumptions, as with the previous case. So there is an observation that is quite striking. We have a number of hypotheses to work with. One hypothesis would be
Probabilmente indicando che
that there is a process
nella fusione di due stelle di neutroni si formano
whereby with the merging of two neutron stars, there is the formation of
che invece spiegano questi due sequenze.
sorry, but I cannot translate because I'm missing so much of what he's saying.
Professore, ci sente?
It's too broken up.
Perché abbiamo problemi
Yes, we're having
di
audio problems. We cannot hear the professor any longer, unfortunately.
digitali nel nostro paese.
Ciolfi, ci puoi fare un riassunto?
Perhaps Cholfi would like to sum it up for us very briefly. Yes, I can certainly confirm that that was the very last thing he was going to say. He was at the end of his talk, so let me just quickly go over what he was saying. So, of course, there are still many open-ended issues that we have to consider, and our main contribution is a theory, this simulation, and it's all very important because we already have some observations that go beyond what we are able to explain. Now, some of the open-ended questions, and this was the very last point that Professor Malazzati was making. Let me just repeat it. I see that his sound wasn't working. So we're trying to understand what would happen exactly and what object would launch this energy jet. There's a 2-second delay. We don't understand exactly between 0 time and 2-second time when, in that window of time, the jet is actually launched. We don't know that in this 2-second window. And we're going to have to study that. Now, the object which is formed is likely a single neutron star, which then collapsed and became a black hole. And if the object was launched before or after this collapse. So our central engine, who launched the jet, was it the black hole or was it the neutron star? So that's our question. That's what we're going to study. And of course, there are many fundamental issues. The state equation of the neutron star, up to what point can it resist a collapse? We don't know what the density of the matter is yet, so we have to study that. These are all questions that are part of this fundamental physics approach. So as I said, they are open-ended questions. Theory is important because we have a lot of material, but we still have to understand what exactly happened there. Thank you very much.
Va bene. Grazie allora per la
Thank you. Thank you for this illustration. Now,
soprattutto il premio per gli 8 scienziati.
we can move on to our award ceremony. We have a plaque with our Aspen silver leaf. This is the Aspen leaf. Each researcher will receive this award plaque. I'm showing it to you now virtually, but you will receive a plaque, and clearly you'll be receiving the monetary prize as well. I must congratulate the 8 scientists, and I don't think there's any problem if we have a round of applause. Thank you very, very much.